Today we're going to be talking about how to analyze statements about logs. So the first thing I want you to do is we just want to give an example of an exponential function. So basically anything to some power. So we'll just choose 5 to the second power. And what does 5 to the second power equal? 25. So that's just an example of an exponential function. Okay? So now I want you to change that exponential function and write it into a log equation. So you need to change that into log form. Okay, so is there anybody that just wants to tell me what it is? Okay, Isabella. That's it. So log base 5 of 25 equals 2. So remember that the base here goes to your base for your log. Whatever your answer is on the exponential one is your number here. And then 2, your exponent goes over there. Okay. So analyzing examples, what I want you to do is write an equivalent statement to 27 to the 1/3 equals 3. So an equivalent statement would be changing that into log form, because logs and log form and exponent form are the same thing, just written different ways. So you're going to work backwards and write this as a log statement. So I'm going to draw a popsicle stick, and I want you to tell me how you write that in log form. Emilio.
Log of 3.
So remember that this number is going to be my base. So it's going to be log base 27. And then, do you remember which number is going to be the big number here? 3. And then that equals 1/3. Perfect. Thank you. Okay, so you're just going to, and you're going to want practice going back and forth. You need to be able to write it both ways. I feel like it's always easier to go to exponent form from log form. And so you can always like double check yourself, like, is this written the correct way? If I were to change this, is it in the correct exponential form? Okay. All right, number 2, you need to write that into what form now? Exponential form. Good. So I'll give you a second to try this. And then I'm going to pull a popsicle stick, and I want someone to tell me what that is in exponential form. Eddie, you were the lucky one. How do I write that in exponential form?
X to the z equals y.
Perfect. X to the z equals y is correct. All right, number 3, same thing. You're going to write this in exponential form, but what are we missing? The base. But what is our base if it's missing?
10.
It is 10. Okay, so we always know if it doesn't have a base, it is base 10. So how will I write this in exponential form, Mandel? Good. 10 to the g power equals d is correct. Okay, number 4, I want you to think about this. Okay, it says, when is the following statement true? So first of all, what would be the answer for this problem?
Or x.
X, okay? X actually equals x. So do we think the answer is going to be for all values of x, for some values of x, for no values of x, or you can't determine?
A. First one. B.
It is B. Does anyone know why the correct answer is B?
Because answers may vary.
Exactly. The reason for that is because we cannot or can't have a negative in that spot. The only place we can have a negative is in your exponent. Do you see how this x right here is like the answer number, and that cannot be a negative? Where's the other place you can't have a negative? In the base. Okay? All right, 5, write an equivalent statement. This one is kind of tricky. And actually, this one, you're almost like simplifying. You always want to look at these, and can you change this to be a base 2? Because if we can change that to be base 2, then your answer just ends up being the exponent, right? So that's kind of your hint. So you're kind of just simplifying this one. So 32 is what is base 2? Good. So if you have log base 2 and 32 is 2 to the 5th, but you still have an x there, what would this end up simplifying to be? 5x. Okay, so I want you to do something similar there with number 6. For a popsicle stick, I just want somebody to tell me what base is this problem on number 6. Myra, what's the base? Good. So when it doesn't say it, it's base 10. So that means we want to change 100 to be 10 to some power. So 100 is what number? Jesse. Good, 10 to the 2nd power, and since I have an x up there, I'm going to keep an x up there. So what is my answer? 2x is correct. Are there questions? Okay, number 7, it says, if the equation of y equals 1/2 to the x power is graphed, which of the following values of x would produce a point closest to the x-axis? Okay, this was back from like the first lesson we did in this unit. But if you're not sure how this is graphed, let's make a t-chart and make a graph. Okay, so if we do a t-chart, we do x and y. We can do, I'm going to do -2, 0, and 2. When I plug these in for x, what is 1/2 to the -2nd power? So when it's a negative power, we end up doing what with the fraction? So it's going to end up being 2 to the 2nd power, which is 4. 1/2 to the 0 power is going to be 1. And then 1/2 to the 2nd power is going to be 1/4. Okay, so if we make a little graph, we have -2 up 1, 2, 3, 4, 0 up 1, and then 2 and 1/4. What points can somebody tell me what values are going to get me closest to the x-axis? Your positive values, right? So that means that on here, oops, sorry, you guys couldn't see what I was doing. So on the graph, as this goes this direction, it's going to get closer and closer to the x-axis. So is it going to be larger numbers or smaller numbers? So you want your largest x value will get you closest to the x-axis. So what you need to remember is always check your fractions. And 5/4 is the same thing as what? 1 and 1/4 as a mixed number. So which one is our largest value? 2, which is C. And that is the correct answer. Okay, any questions there?